Welcome to today's class. We're in McDougall's Math, and we are going to be covering simple and compound interest today. I know they are, of course, your absolute favorite topics to cover. You know, for those of us who have a good amount of student loans to pay back, but they're probably really great for those of us who have, bank accounts with more than $1 in it, and they're adding a little bit of money on top. So, simple interest is money paid on top of a principal amount of money. So either money borrowed or money invested in something. So principal is going to be the amount of money borrowed or invested. Your rate is going to be the percent earned. Again, earned if you invested in something or have a bank account and they add money to your account, or your percent charged. Those would be for those of us who have student loans. And time is going to be the length that you have the loan. And this is always going to be described in years. Always, always, always described in years. Seems like a lot of writing. I don't know why I'm writing. Honestly, the main thing you need to understand is I'm going to give you a formula, and you're going to need to learn how to identify what is each amount in a word problem, and where do I put it into the formula? So let's give you the simple interest formula. Let's erase all this. The simple interest formula is really just I is equal to, let's color code a bit, the principal, P, times R, or rate, times, let's see, what color do I like? How about purple? Times time. I equals PRT. I had a student earlier today, either earlier today or yesterday, say, "Oh, I purdy," and I had to make a terrible teacher joke just because of it. So, if we think about it, this is our simple interest. P is our principal. R is the rate. And T is time in years. It looks like a lot. You're going to probably be a little bit more weirded out, especially when I show you the compounding interest formula. But this is really just as simple as plugging in some numbers. Let's give you a hypothetical here. I'm going to say Mr. McDougall borrowed some money from the bank. Don't worry, this isn't my actual loan. Mr. McDougall borrowed a certain amount of money from the bank. So let's say $130,000 from the bank. That's a high-end student loan. It's not what I'm really at. And promised to pay them back over 5 years at a simple interest rate of 7%. How much interest will I pay if I pay off the entire loan at the end of 5 years, or I start paying at the end of 5 years? And how much will I have to pay total? So what can we pull out of that problem? If I read it again, I know that my principal amount is how much I borrowed originally. In this case, it's $130,000. I know my rate from reading this is going to be 7%. I know that my time in this loan case here is going to be 5 years. I do believe we've got enough stuff to plug in. So, simple interest is equal to 130,000 times the rate times the time in years. And we can hit at this in any order we want, really. 130,000 times 0.07 is going to give us $9,100 times 5. If we simplify that even further, we're going to get $45,500. Now, in my original question, what did I say? If that's just my interest, how much do I have to pay total? How much am I going to have to pay total? All right. The total amount is equal to, here's a hard formula, kids, your principal plus your interest. So, hard formula, we got to add now. 130,000 plus this new number here, 45,500, and we get $175,500. There's nothing wrong with going to City College first and saving a little bit of money. Save your money, work hard, and go to your major at a really major specific university. All right, that was simple interest. Let's go over something called compound interest. Now, compound interest is not just interest paid on your principal or your initial investment, but it's also on the interest being earned. Now, when you get a problem, or when you talk to your bank, you'll say, your investment is going to be paid back in a compounded fashion, and it's going to compound at different periods. The only extra thing that we need to know here is our end value. And in this case, it just means compounding periods. So, our compounding periods, some words that you're going to need to get used to are annually. You're going to need to see semi-annually. Your parents might be able to understand this. Quarterly and monthly. Annually happens one time a year. Again, let's think of our root words. Annually, one time. Semi-annually. Twice a year. Quarterly happens 4 times a year, so every 3 months. Every 3 months. Monthly, it happens every month. How many months are there in a year? 12. All right, now that we've got that down, let me give you a beastie of a formula. The compound interest formula is P times the sum of 1 plus rate over our new little friend here, rate over, I need to get a new color for that. I found some new pens in my room, and not all of them are great. Let's just make that blue too. Compounding periods. Rate over the compounding periods raised to the power, the exponent, of our compounding periods times our time. So we have our principal times the sum of 1 plus the rate divided by compounding periods. That inside the parentheses is raised to the power of our compounding period times time. Let's have a hypothetical here. Let's say our principal is equal to, let's make it a small number just for the sake of things, 2,000. Our rate is, say, 5.5%. Let's say this is going to be compounded. Well, let's go quarterly. Let's be nice. So n is equal to 4, aka quarterly. And our time period for this loan is going to be, let's go with 4 years. Let's keep it small. So let's plug in some numbers and multiply. So our principal times 1 plus our rate, 5.5%, over our compounding periods, raised to the compounding periods times the time in years. Let's bring all this stuff down a little bit more. 2,000 times 1 plus 0.55 divided by 4, which is 0.01375 in this case, raised to the power of 16. Simplified a little bit more, 2,000. Let's add what's inside of this parentheses here, 1.01375 raised to the power of 16. Now, I'm not going to be mean to you in more class. Let's be honest. If you can raise this number to the power of 16, that is just going to be an excessive amount of work. So, what I want you to end up doing is look at me, I'm unprepared here. Make a little bit of room. Let's just do this. What is 1.01375 raised to the 16th power? We should get inside of that parentheses there, round it off to 1.24 just for the heck of it. So we get this little number here by multiplying this number right here. So now we've got 2,000 times 1.24, and that should give us $2,480 of compounded interest. I hope you enjoyed that episode of McDougall's Math. I know that was a long one. Try teaching in the middle of class. Some of you are used to that. Alright, I hope you have a great rest of your day, and I will see you guys in class tomorrow.